Okay, chapter 4, rate, ratios, and proportions is kind of like chapter 3. And what we're going to do is add some language to it now because most of chapter 4 will be about story problems. First thing we need to go over is right here is some definitions. First definition, of course, is for ratios. And a ratio is just two quantities that share the same label. So you can compare a number to a number, for instance, the 3/4 up there, or people to people, miles to miles, gallons to gallons, and so forth. It's just two numbers compared to each other. And they have the exact same labels. The next one we're going to look at is rate. Now, rate is the A in that means change, okay? Unlike the ratio, the O in there means steady rate, okay? So it means the same. In the Greek, A means changing. So if you can remember that, it's the change. So it means two distinctly different things we're comparing to each other. So they have two different labels. For instance, miles per hour, minutes per second, miles per gallon. Those kinds of things we're going to compare to each other. So just so you remember. Now a ratio is stated as, here's an example, 15 to 3, and we write it like this. You can also write it like 15, and then you use the colon, semicolon, compared, let's put another one in here, 5 compared to 3, and it's not letting me do it, but that's the whole thing. Let's see if we can get, there we go, 15 compared to 3. And every time I hit a number, it's changing. So there we go. 15 compared to 3. That is how it's written in its formal form, but the way we need it written is in the fraction form. Proportions is the next thing we'll look at. And it's a statement that compares two rates or two ratios that are equal. So you're going to write it as A over B equaling C over D. And when we get there, it'll be a little more explanation to it than what's here. Okay, it's just the definition. So here, let's start using some of it so that we can figure out what to do. The first thing we're going to do is look at this first story problem right here. A college has 2,520 students and a teaching faculty of 154. What is the rate of students to faculty? Well, if you remember to look at it, it tells you how to set it up. Students, this is fun trying to write, A-N-T-S, compared to faculty. And I'm just going to put a F there, just shortcut this. So all I have to do is fill in what they asked me. I have 2,520 students compared to the number of faculty that teach, and they want to know, what is that rate? What is this? If we actually reduce this number, we're going to come out with a smaller number, and when you do the math, it would be 180 students for every, let's see, I'm doing it in my head, just a minute, for every 11 teachers. So we'll put faculty there. So that's how you would read it. I have 180 students for every 11 faculty they share. That's setting it up. So it says comparing students to faculty, students over faculty. Because this is an improper fraction, I have to reduce it to the rate, because we're comparing students to faculty. It's a rate, even though they're people to people, there are students and faculty different labels, so that's why. And I had to reduce it to its lowest terms, just like we did in the fraction section. Now, let's go to the next one I have here. We'll change that. Now, if a car travels, let's see, this is Apple software. I'm not used to using Apple. There we go. The next one is comparing miles to hours, and they want the unit rate. Well, the unit rate is just that. We're two labels, miles to hours. So what we're doing here is comparing miles to hours. And it's just like the problem overhead, the one we just did. So all I have to do is 416 miles compared to 8 hours. And then I have to do the reduction. And of course on your calculators, if you've looked at the site, you can come up with this. You're going to end up with 52 miles compared to 1 hour. That's the rate. And we know that we can write this a little differently. 52 is a whole number over that 1, but if we put the label on it, miles per hour, so write MPH, we know that the 1 is in there. Okay, so this is the formal way to write it so that the label is there. That's in its lowest terms. Now I know this is kind of going a little fast. There's a lot in chapter 4 to cover, and this is just the basic setup. So I wanted to get to what I consider the meat of the chapter as quickly as possible, so you don't have to watch 2 videos this time. You could just watch 1. Okay? So let's move forward here. We're going to look at proportions, and remember what I said earlier. We're going to take the proportions and we're going to say it's A over B, and don't let this, formal language mess you up. And then you're going to have C over D. That's what we're going to set up with these next story problems so that you can see. And the first thing we're going to do is look at one and compare it to see if it's equivalent. So 7 over 56. The question is, does it equal the next side, which is going to be 3 over 24. Now, to figure out if it does, we're going to learn a process called cross products. We're going to take 7 times 24, and we're going to see if it equals, this is the question, the next step, which is to multiply, this is step 2, the bottom to the top, which is 56 times 3. Now I'm teaching you to set it up in an equation form, and that's a question at this point. We don't know if it's a true statement, to see if it is a true statement. So if we multiply this side, we're going to get a 168. And does it equal? Multiply 56 by 3 and you'll get 168. So this is a true statement, so this remains the same way, okay? That's one example. Now let's jump over here and do another example. Let's do 64 over 5. I've written out some problems so that I can demonstrate with you. Does it equal 89 over 7? Remember, it's a question. Does it equal? We don't know. So we're going to take our steps. First step, cross products for this side, which is 64 times 7. Does it equal, second step, 5 times 89, 5 times 89. Now let's do the math and see if it's a true statement. Let's see, this becomes 448 when we multiply 64 times 7. And then over here we have 5 times 89, which is 445. So this is not a true statement. This means not equal to. So we know this is false. And you're going to work on some of these. You can find some that are true. You can find some are false. And it's to teach you the method of setting up an equation. That's the purpose for this, plus to find out if it's true or false statement. Hopefully that was a little bit helpful. I'm not sure, but as we go forward, I'm sure it'll become clearer what we're trying to accomplish here. The next step in this process is to actually find an unknown. So here we go. We're going to start with, excuse me, 17 over the unknown of n, and I just chose n for the heck of it. It could be any letter. You can use whatever you want. And then I'm going to have 51 over 9. Here's a proportion that we're going to write in an equation form and learn to solve equations. First step is to compare these two numbers on this side. 17 times 9 equals, second step is going, to be in green, 51 times n. The variable, which is n in this case, is always after the number, okay? So that's the proper form to write it right there. So when we multiply that, we end up on this side with, let's see, we'll change colors. On this side, we're going to end up with 153 equals 51n. Now, when we're at this stage, we're at an equation that you're going to learn in the next course, okay? In order to make this side just n, we're separating out, okay? So there's another step, and I'm going to rewrite this whole step right here so that you have all of the steps to look at in this little video that I'm doing. Our next step then is to divide both sides. This is a process of multiplication. To undo n times 51, we have to divide. And we always use the number in front of the unknown. This creates a 1. And 1 times n is n. What we do on one side of the equals, we have to also repeat on the other side of the equals sign to keep the balance in the equation. If we don't, the whole process will fall out. Now when I do the actual math here, I end up with a whole number 3 because 51 fits into here 3 times. So that's the process. This process right here is called the funnel down method, okay, because it looks like a great big funnel. You put in some information and you end up with one thing coming out as the answer and you're solving it, okay? So let's do one more just as an example so that you have something to go by, and we're going to change where the variable is. N over 4 equals 49 over 48. Step 1, let's look what that is. Multiply these two together, I get 48n equals, second step is 4 times 49. We're using cross products so that we can create an equation. Now, of course, on this side, I can simplify this side. This is 196 when we multiply this. And we still have the 48n. It hasn't changed yet. Remember, this is an unknown number times a number. It is a process of multiplication. So because of that, we know that we can undo multiplication in this case by division. Division on both sides keeps the problem equal. So we're going to divide by the number in front of the n. This is called the coefficient of the unknown variable, okay? But just it's the number in front to you. Which means we also have to repeat this process on the other side to keep it. This becomes a 1. 1 times n is n. I can't repeat that enough to get it so that you understand it is a 1. A number over a number is 1. 1 times whatever is left is that thing that's left. When I divide now, I'm going to get 4.08. Whoops, it didn't show. That's how you do cross products. Now that sets up our next step. We're going to create a proportion reading story problems. That is the real meat of this course, okay? So I'm going to read a story problem to you and then we'll set it up. Bob purchases 8 notebooks for $19. Okay, so he buys eight notebooks for $19. And there's my symbol for that, the other label. Notebooks compared to dollars, so it's a right. Then the next thing it says, how much would 14 notebooks cost? Well, notebooks are here, so notebooks have to be here. And they want to know how much would 14 of these notebooks cost. So how much do they cost? We don't know. I'm going to substitute something in here. For instance, I think I'll put a C here for cost and we won't keep the dollar sign. The point is, this becomes my unknown because that's what I'm looking for. And it's just like we did. Set it up first. They're going to compare an object to an object. In this case, Bob bought 8 notebooks for $19. How much would 14 notebooks cost? They said notebooks to cost was the first comparison, and I have to keep the comparison equal. So this is notebooks to cost. And in this case, we set up the 8 notebooks for the $19, 14 notebooks for how much? That's what we're going to find. So this side here, step 1, 8 times C is 8C. And the next objects we compare is the 19 times the 14. So now the 8C is going to equal, do your math now, 266. Now we still have 8C equals 266 because I don't want to skip any steps. But now we need to get rid of the 8 in front of the C. It's a multiplication, 8 times C. So to divide it out, because it's the opposite operation of multiplication. This becomes our 1 now. 8 over 8 is a 1. 1 times C is C. And how much would 14 notebooks cost? And it's $33.25. And that's what we were looking for, so we write it as the cost. That means that 14 notebooks would cost $33.25. Now, you can look at this problem a little logically. If $19 bought 8, we know that we have to be higher than $19, so we can assume that we're correct. If you wanted to check this problem, you could just simply put 8 over 19. Does it equal 14 over the $33.25 that we just had? You could do cross products again, and when you do that, you'll find out that this is equivalent and it's the correct answer. So you could check these on your calculator if you'd like. It's a good thing to do. Just right now, time consuming, I need to get the video done. I want to do one more example so that you can learn to set these up. Emily bought 10 mechanical pencils. Okay, so let's write that down. She has 10, and I'm going to use a P for pencils, for $24. So the symbol here takes care of that. Now it says, how much would 15 pencils cost? Okay, so the question is 15 pencils, and how much dinero would it cost? Again, it's just reading the problem. They always set it up. They give you an example, the 10 compared to the 24. What would be the comparison of 15 to the cost? So it's a matter of reading the statement, understanding how to write the statement. Again, it's just the process of cross products again, so that you can set up 10 times C This was just a reminder that pencils are compared to pencils, cost to cost, always that way. Equals 24 times the 15. This side remains the same for a little bit, and we complete this operation, which is just multiplication. So this becomes 360. Now the next step, remember, we have to divide both sides to keep equivalency, and we divide by the number in front of the c called the coefficient. This becomes a 1. 1 times c is c. And if you wanted to reduce right away, you could see the answer is 36 what? It was a cost, so it's not correct until we put this sign in front because it's $36. And if you wanted to, you could even do this part so it was really clear. To check your answer, you would just simply come over here and do 10 over 24. And does it equal 15 over 36? You would do 24, well, I'll do it 10 times the 36 because I've been showing you one strict way, right? Because we did this. Does it equal, and the next step would be the 24 times the 15. And when you do the math, it will equal this side